Welcome to Mrs. Bibb's Algebra 1 class for week 14. This week we'll be working with exponents. It's reviewing something that you learned when you were in 8th grade in middle school. Please make sure to fill in your table of contents, complete your weekly warm-up and check it. You will need Student Journal page 172 for this lesson. This is page 55 in your notebook. Looking at number 1 for the extra practice. This is a property of exponents that you need to remember. Anything raised to the 0 power, and I believe you would see it as a raised to the 0 power. A raised to the 0 power is 1. So anything raised to the 0 power is 1. Now, sometimes, if you would happen to have negative a to the 0 power, that means the opposite of a to the 0 power. So that would actually be negative 1. If you had this, negative a, which is what that says inside the parentheses, raised to the 0 power is positive 1. So it does make a difference the way it's written as to which answer you will put. You may want to write down these on the side just to remember these little properties of exponents for the power of 0. Looking at number 1, 3 to the 0 power is 1. Number 2, negative 2 raised to the 0 power is 1. Another property of exponents, a negative exponent. If you have a base raised to a negative exponent, in mathematics it's not considered to be simplified if you have a negative exponent. To make that exponent positive, you move it. Right now, currently, the base that contains a negative exponent, the base a, that contains the negative exponent of b, is in the numerator. In order to make it a positive exponent, you move it to the denominator, make the exponent positive, and there has to be something in your numerator, so you would put a 1. And then, of course, if you have a base that's a number, you would want to simplify that number. Looking at number 3, I have a base of 3 raised to the negative 4 power. To make that a positive 4 power, I move 3 to the denominator, make it a positive 4, put a 1 in the numerator. Then I do need to evaluate that 3 to the 4th power. 1 goes in my numerator. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. The answer to number 3 is 1 over 81. Same thing for number 4. I have a base raised to a negative exponent. To make it positive, I move that base. Even though the base is negative, you move the base. Negative 4 moves to the denominator. Only your exponent becomes positive, and 1 needs to be in the numerator. Now for my final answer, I'll put it right here. 1 will be in the numerator. Negative 4 to the 3rd power. Negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. So negative 1/64 is the answer to number 4. Moving on to number 5, I'm going to simplify my denominator first. 5 to the 0 power is 1. I'll bring over my numerator of 2 to the negative 3rd. I need to move that base of 2 to the denominator, make it a positive exponent of 3. Keep that 1 in the numerator. Then evaluate 2 to the 3rd power. 2 times 2 is 4, times 2 is 8. So the answer to number 5 is 1/8. Number 6 is a little tricky. Let's make our exponents positive first. Okay, how do I do that? I have a base in the numerator that has a negative exponent, and I have a base in the denominator that has a negative exponent. Well, you move both of them. First, I'm going to move the negative 3 base, or the opposite of 3 base, to the denominator, and make that a positive 2 exponent. I'm going to move the base of 2 to the numerator and make that a positive 3. And now, 2 to the third power. 2 times 2 is 4, times 2 is 8. In the denominator, now this is tricky. There's a difference between negative 3 to the second power, or the opposite of 3 to the second power, and negative 3 to the second power. Those do not give you the same answer. I have the opposite of 3 to the second power. 3 to the second power is 9. The opposite of 9 is negative 9. So the answer is negative 8/9 for number 6. Moving on to number 7. I only have one negative exponent, so I'm going to move that to the denominator. I'm going to keep my opposite of 7 to the 0 power in the denominator, and I'm going to move 4 to the denominator and put a positive 1 power. Next, the opposite of 7 to the 0 power. This matches this rule. So instead of positive 1, 7 to the 0 power is 1. And then the opposite of 1 is negative 1, times 4 to the first power is 4. And so I would get negative 1/4 for my answer for number 7. Then for number 8, my base of 3 is a negative. So I'm going to move that base of 3 to the denominator and put a positive 1 power. Negative 5 to the 0 power remains in the denominator with a 1 in the numerator. Next, I'm going to evaluate negative 5 to the 0 power. Anything to the 0 power is 1, and that is a negative 5 raised to the 0 power, so that is 1. 3 to the first power is 3, and then multiply my denominator, so number 8's answer is 1/3. Now we're going to do the same thing, but we're going to use the variables. Remember, if an exponent is negative, move the base to the opposite place that it is and make it positive. Number 9, z to the 0 power. Anything to the 0 power is 1. Number 10, a to the negative 8 power. To simplify, move your a to the denominator, make the 8 a positive, put 1 in the numerator. That's your answer. For number 11, I have 6 times a to the 0 power, so that's 1, times b to the negative 2. Now I need to simplify the b to the negative 2. I can also simplify 6 times 1 at the same time. 6 times 1 is 6. Move b to the denominator with an exponent of positive 2. That's your answer to number 11. Number 12, I can do all the movements at one time. 14 remains in the numerator. M goes to the denominator with a positive 4 exponent, and n to the 0 power is 1. So 14 times 1 is 14 over m to the 4th power. Looking at our next problem, I see 2 negative exponents and an exponent of 0. I'm going to take care of that exponent of 0 first. S to the 0 power is 1. 3 to the negative 2 power will move to the denominator with the 1 and make that a positive 2 power. R to the negative 3 power will move to the denominator with the 3 and be r to the positive 3 power. There's nothing in the numerator. Then to simplify, I have 1 over 1 times 9 times r to the 3rd, and the best way to write that answer is 1 over 1 times 9 times r to the 3rd is 9r to the 3rd power, or 9r cubed. Number 14. There's a lot going on in this problem. For number 14, right away I see I can simplify 2 to the 3rd power. The reason why I can go ahead and simplify it is my exponent is a positive. 2 to the 3rd power is 8. I see that this c to the 0 power is 1. I'm going to go ahead and mark it out and put times 1 because I don't really need it there. Now, everything else, I've used this also, I've taken care of that. Everything else, a to the negative 3, 8 to the negative 1, and b to the negative 5, I need to move them and make their exponent positive. A to the negative 3 moves to the denominator and a positive exponent of 3. 8 to the negative 1 moves to the numerator with a positive exponent of 1. B to the negative 5 that's in the denominator will move to the numerator with an exponent of positive 5. Of course, 8 to the first power is 8, and I'll simplify my numerator. 8 times 8 is 64. 64 times b to the 5th is 64 b to the 5th power. And a to the 3rd power has nothing to simplify with it, so that is my final answer. We've only been multiplying, not really dividing yet, although the answer to number 10 and 11 and 12 and 13, so on and so forth, 14, those all are division problem answers, but we haven't actually had to divide bases yet. So remember, here's a couple little rules you got to know. First of all, when you're multiplying like bases, you add exponents. When you are dividing like bases, subtract exponents. So for 15, I have like bases. This is the rule that I use. You probably would never see this in a textbook, but I just use this rule. When I am dividing my like bases, I divide from where the exponent is the largest, and I know that's where my answer is going to be. So when I look at number 15, I have 3 to the 5th divided by 3 to the 3rd. 5 is larger than 3. It's in the numerator, so I know that my base of 3 is going to be in the numerator, not the denominator. And then I subtract my exponents. So 3 to the 5 minus 3 is 3 to the 2nd power. Then if you can simplify, if you can evaluate, you should. Can you find a numeric answer for 3 to the 2nd power? Yes, you can. 3 to the 2nd power is 9. That's the answer to number 15. For number 16, I do have the same base. Negative 2 is the base. I have an exponent of 7 and an exponent of 5. Where is the base's exponent the largest? Again, that's in the numerator for this one. So my negative 2 is going to be raised to the 7 minus 5 power, which is negative 2 to the 2nd power. And then negative 2 to the 2nd power is positive 4. That's the answer to number 16. Now looking at 17, do I have the same base? Yes, negative 5 to the 3rd and negative 5 to the 3rd. So I'm multiplying like bases. What do I do to the exponents when I multiply like bases? I add the exponents. So negative 5 to the 6th power. Now I may need some help with this one. Negative 5 times negative 5 is 25. 25 times negative 5 is negative 125. Negative 125 times negative 5 is negative 625. No, positive, because we've done that 4 times. And then positive 625 times 5 is 3125. And that's a negative 3125. And then negative 3,125 times negative 5 I think 15,625 positive. Let me grab a calculator and check. That is the correct answer, positive 15,625. All right, 18. I have a base of q to the 5th power and then raised to the 3rd power. This is called power of a power. And I'm going to erase this math over here so I can put this next rule. Here's another rule you have to remember. When you have what's called power of a power, two exponents stacked on top of one another, power of a power, you multiply the exponents. Okay? So, q to the 5th raised to the 3rd power is q to the 5 times 3. And then 5 times 3 is 15. So q to the 15th is the answer to number 18. 19, there's one of two things you could do. You could go ahead and take care of your power of a power and then take care of your negative exponent. Or you can take care of your negative exponents and then take care of your power of a power. Personally, I just like to go ahead and multiply those exponents here. So I would do a to the negative 4 times 2 and simplify that, which would be a to the negative 8. And then I know I'm not finished because I have a negative exponent. So then I would put 1 over a to the 8th power. And that is my answer to 19. For 20, I have two different things going on. I have multiplication in the numerator, and then I have division. So I'm going to take care of my numerator first. C to the 4th times C to the 3rd is C to the 4 plus 3, divided by C to the 6th. 4 plus 3 is 7. And then I have like bases. I'm going to subtract my exponents because this is division of like bases. My exponent is largest in the numerator, so it's going to stay in the numerator. It'd be c to the 7 minus 6. And c to the 7 minus 6, when you just do the math there, that's c to the 1st power. But I'm going to erase that 1st power. I wrote it there just for a moment. The reason I'm erasing it is that it's understood that that's c to the 1st power there, and you don't want to be redundant putting a 1 when it's understood that a 1 is there if there's no exponent. And that would be the answer to number 20. It's just c, or c to the 1st power. For number 21, this is called power of a product. For your power of a product, you're going to make sure that each thing inside the parentheses gets this exponent of 4. Negative 4 will be raised to the 4th power, and d will also be raised to the 4th power. When we get to actually doing polynomials, binomials, trinomials, you'll see a mistake that students make. They use this power of a product rule when they have a sum or a difference, and I'll talk about that more later. But I just want to point out, you only do what I'm doing here when you have power of a product. Now, I'm going to multiply my exponents. What exponent is understood to be on this negative 4 on the inside? That's a 1. And what exponent is understood to be on this d on the inside? That's a 1. So to do my power of a power, I'm going to multiply 1 with each of those exponents. Negative 4 to the 4th power means negative 4 times negative 4 times negative 4 times negative 4. And let me go through that. So that'd be negative 4 times negative 4 is 16. 16 times negative 4 is negative 64. And negative 64 times negative 4 is positive 256. And then d to the 1st power raised to the 4th power is d to the 4th power. That's my answer to 21. For 22, I'm going to do the same thing. I'm going to raise each term. Actually, I changed my mind. Since this entire thing is raised to the negative 3 power, I think it's easier if you go ahead on this particular problem and put that expression negative 3f to the positive 3rd power in the denominator. And then do negative 3 raised to the 3rd power and f raised to the third power. Then negative 3 to the third power is 27, and then f to the third power is f to the third power. The answer to 22 is 1 divided by 27 f to the third power. Last one, number 23. Now we haven't encountered this yet. I have a fraction raised to the negative 3. The quickest, fastest way to get this one completed is to know that when you have a fraction raised to the negative 3, that rule actually looks like, let me go to the very top and show you. That rule looks like this: a divided by b to the negative c power. All you have to do to make that a positive c is to do the reciprocal of your fraction. Oops. So a divided by b turns into b divided by a, and then make that a positive exponent. That's all you have to do. Do the reciprocal of your fraction, make that a positive exponent. That's what I'm going to do here. So my first action is to do the reciprocal of 4 over x and make that a positive 3. Now I'm going to do a power of a power, x to the third power. Actually, it's power of a quotient this time. That's what this one's called. So x to the third power divided by 4 to the third power. X to the third power is x cubed. 4 to the third power is 64. And I'm right at the bottom of my paper there, or my iPad screen, so I can't make that 64 look right. That is x cubed divided by 64 for number 23. I believe that's the last example. I could be wrong. Let's look at the next slide. Oh, I was wrong. One more. So for 24, this is like a multiple select question, because it says select all that apply, so there could be more than one answer. It says a rectangular prism has length x, width x over 2, or x divided by 2, and height x divided by 3. Which of the following expressions represent the volume of the prism? Select all that apply. Volume of a prism is going to be length times width times height. My volume would be x times x divided by 2 times x divided by 3. So this particular answer, if I were to do this, would be x to the third, x to the first times x to the first times x to the first. Add your exponents would be x to the third. 1 times 2 is 2, 2 times 3 is 6. So this is the actual volume with the facts that I've been given. How many of these would be equivalent to x to the third over 6? Let's just go through them. For this first one, 6 would need to move to the denominator. X to the third would remain in the numerator. Is that the same? Yes, so A is correct. For the next one, both bases are raised to a negative exponent, so they're both going to go to the denominator, and the exponent is going to become positive. And that is not equivalent to the volume that we just got. For the next one, I'm going to move this to the denominator and make that an exponent of positive 1. I'm going to, that's a negative 3 also. It does not change that x to the negative 3. It doesn't change the exponent to a positive 3 because you're only moving it because of this exponent. Now, when I do my power of a product, I'm going to do 1 over 6 to the first power times x to the negative 3 power, because I'm multiplying 6 to the first times 1, which is still 6 to the first, x to the negative 3 times 1, which is still negative 3 for my exponent. And then I still have a negative exponent, so 6 will remain in the denominator, and that x will go to the numerator with a positive 3, and that is the same. And one more. Negative exponent, so that's going to go to the denominator, 2 to the first times 3 to the first. X to the third has a positive exponent, so it stays. And then 2 to the first times 3 to the first is 6. So that's also a yes. All of them were equivalent except letter B. So that's how you go about doing that kind of problem. I hope that you understand the properties of exponents with variables and with numbers. And if you need any help with anything, please reach out and let me know. You'll have a Reimagine Time assignment. It looks like there's not bookwork. You'll have an assessment at some point, and you'll be able to check your answers, and that will be all for this week's lesson. Have a wonderful day, and if you need any help, please let me know. I'm here to help you.